Hello and welcome to a screencast on properties of common minerals. You should have page 16 of your Earth Science reference table out in front of you while we go through this. We're just quickly going to do an overview of how to read this table. It's not too difficult, so follow along. You can see here we have properties of common minerals. We have the luster, the hardness, the way a mineral breaks, whether it demonstrates the property of cleavage or fracture, common colors, distinguishing characteristics, the uses for the mineral, the chemical composition of the mineral, and then finally the mineral name. Let's start with the luster. The luster of a mineral tells you whether or how it reflects light. So we have a metallic luster and we have a non-metallic luster. On this table here, we have one mineral that can display either a metallic or non-metallic luster, which would be hematite. The next column, we have the hardness of the mineral. This is on the Mohs hardness scale. 1 would be the least hard, so it would be soft, and 10 would be the hardest. However, on this particular reference table, if you scroll down to the bottom here, you'll see that garnet is the hardest one displayed on this table, which has a hardness between 6.5 to 7.5. Whoa, too far. Okay. For our metallic minerals, the softest metallic mineral that we have here is graphite, and the hardest metallic mineral we have is pyrite. For our non-metallic minerals, the hardness of 1 here, this would definitely be a soft mineral, we have talc. And for the hardest mineral on the reference table, here we have garnet. In the next column over, we have how a mineral breaks. It either demonstrates cleavage or fracture. And you'll see that there's a check mark here in the columns to say whether or not that mineral demonstrates the property of cleavage or fracture. So graphite here has a check mark under cleavage, therefore it demonstrates that property. Now what are we talking about when we talk about cleavage or fracture? If a mineral demonstrates the property of cleavage, it means that it breaks along smooth lines. You can see here that this mineral has a cubic shape. That's because it breaks along smooth lines, kind of like this mineral over here. You can see this cubic breakage here on this mineral. This is the property of cleavage, which means if you took a hammer, which we're not going to do, and you broke these minerals, they would still break along these smooth, clean lines. This mineral right here has a metallic luster, and it also demonstrates the property of cleavage. It breaks along smooth lines. You can kind of see this cubic breakage here. These two minerals are non-metallic luster and also demonstrate the property of cleavage. Looking at these two minerals here, these are two non-metallic minerals, and these two minerals demonstrate the property of fracture. So they do not break along smooth lines. Here we're comparing two non-metallic minerals. One on the left here is demonstrating the property of fracture. The other non-metallic mineral on the right-hand side is demonstrating the property of cleavage. Next we have common colors. Now typically when you look at a mineral, the first thing you're going to see is the color. However, the color is the least useful way to identify a mineral. They do list some common colors, and you can take a look at that. However, some minerals, such as garnet or quartz, come in so many different colors that it does make it the least useful way to identify a mineral. We have distinguishing characteristics, which comes after common colors. This just gives us some ways that you can identify the mineral, maybe by doing some tests. It makes it different from other minerals, such as calcite and dolomite. It says that it bubbles with acid. This is a distinguishing characteristic for it because not all minerals would bubble with acid. Some distinguishing characteristics might be the directions that it breaks in. So this tells you that fluorite breaks in or cleaves in 4 directions, as opposed to pyroxene, which cleaves or breaks in 2 directions at 90 degrees. Next we have the uses for common minerals here. if you just look down, it'll tell you what they're used for, such as talc is used in ceramics and paper, and then you have garnet, which is used in jewelry or as an abrasive, and that's really all I have to say about that. Finally, over here we have the composition. This is the chemical composition of the mineral. So you can see graphite, chemical composition is carbon. You scroll down, you can read through all this. Now, if you don't know what each and every one of these symbols stands for, if you go down to the bottom of the reference table sheet, you'll see chemical symbols. So if you're not familiar with your chemical symbols, it's okay. Just look at the bottom of the sheet. I hope you found this screencast helpful, and thank you for watching.